Hi. In this video, we'll be talking a little bit about requirements. What is a requirement? How do you do requirements? Ask somebody learning how to program what the most difficult part of building software is, they'll tell you coding, or testing if they have a little bit more experience. But ask a veteran software engineer, and they'll tell you, it's getting the problem right in the first place. This problem is compounded by a number of factors. First, building software is the most complex thing we've ever done. Building dams, rocket ships, and nuclear reactors is hard, don't get me wrong. But in each of those cases, you're building something concrete. You can see it, you can touch it. You can't do that with software. The fact that software is intangible, that it cannot be touched, makes anything much more difficult. Because of that property, it makes it very difficult to communicate exactly what we mean when we're talking with other people about our problem, and it's the proposed solution, because you can't see it. Add on top of that talking to the user. They may not know what can be done to solve the problem. They might not even know what they want. And two different users of the exact same system may want two different things. And they could even call those two different things by one name, confusing everybody even more. So what we do then is define a little bit of rigor into this very nebulous process. We define our requirements specification. So what is a requirement? Well, what is a requirements? Well, it's really two different things. First, it's a process. The process by which we create our shared understanding of both the problem that exists and eventually the needs of our supposed solution, which we want to build that will solve that problem. We create high-level descriptions of all the concerns we hope to address by our work, with the primary goal of developing a document which can clearly describe the details of what the system will do versus what it won't do. Additionally, it's very important we capture the what and not the how. We hope to determine what the behavior of the solution will be without making any premature decisions that might affect our ability to design the solution. The design solution will be decided, but not at this stage.
I wanted to give you a brief overview of the process of software engineering and where the process of requirements engineering sits in there. So when you take the overall software engineering process, we have a few phases. It starts somewhere here. First mistake. I was going to write software engineering up into this one, but that's actually the headline. So erase that, start again. So software engineering is the entire thing. Then this first part here is what we call requirements engineering. After requirements engineering, we go into design. From there, we move on into implementation. From there on into testing. And then we have deployment and installation. And finally, maintenance and evolution. This is like a model of the very basic software engineering process. One of the really cool old school professors in requirements engineering, his name is Al Davis, used to say, essentially, all models are wrong, but some of them are useful. And what he means by that is that any model that we make, conceptualize, draw of something is an abstraction of the actual thing. Because if we try to represent it in all detail, then it would be so complex that it's not very helpful. So we abstract from the reality, we simplify, and that way we have an easier time to get things in our head. Now, one of the abstractions of this model is we're usually not starting from scratch completely. That may be the case sometimes, but for many of the systems that you'll be working on later, there will be previous systems that you either need to replace seamlessly or where there has been an old system in place and now there is a significant shift in technology and you have to introduce something new. On the other end, we're also not going to end in nirvana, hopefully. There will be a continuous process, and at some point there may be a loop back here. We have to start again with requirements engineering. We've maintained the system over time, but eventually the system has been fixed and patched in so many different places that there just needs to be a significant overhaul, and then we start again over here. That is one of the simplifications. The other one is, this implies a linear process. Ain't happening. For those of you who already have a little experience, even just in developing a small app, you know that you start somewhere here, you get to a design, you start implementing, and then you're like, oh, this didn't quite work as I thought it would. Okay, so you have to go back and fix the design, and then you implement again. Or you figure out during testing, wait, this is not really doing what we said we were going to do in the requirements. Go back, fix it. Go back, talk to the stakeholder, find out what they actually needed. Fix the design, fix the implementation, back to testing. Hopefully move on into deployment. So that's the next simplification. There are actually feedback loops here that go back. But this you may already have heard of in earlier software engineering courses. Requirements engineering has 4 major phases. The first one is requirements elicitation. This means I ask stakeholders for their wishes, their constraints. I find out about their needs. And then once I have all this knowledge supposedly in my head, and I'm saying supposedly because it's not as easy as go interview 3 people, come back, write everything down, and you're done. You probably have to go back a couple of times and clarify. You have to find out, oh, I also need to talk to the person over there. And I need to call that person in the other time zone. And sometimes you only find out here, oh, there was somebody else who I should have talked to here. We'll get to that problem later. So after requirements elicitation, what we do is requirements analysis. And requirements analysis is basically, I look at the set of requirements that I have written down, and I try to find out whether they fit together. Are they consistent with each other? Or are there any contradictions where one requirement says, we are gonna need to stay below $10,000 for the development of this product, and the other requirement says, we need to have availability 24/7, which means we need at least 1 redundant server, which means we're going to run way over $10,000 budget. So we have a so-called conflict in our requirements, which means we need to go back over here, talk to stakeholders, and resolve the conflict. Next phase is requirements documentation. That means I write it up in a way that I can go back to the stakeholders and say, this is how we understood what you were telling us. Are you going to sign off on this, that we are supposed to develop the requirements on this basis? And doing that is called requirements verification and validation. Wait, now, which one is which? Verification, validation. So verifying requirements is, did I correctly write down what these people said? Validating the requirements means I go back to these people and ask them, is this what you really need? So what we use as a mnemonic for verification and validation is, verification is, am I building the system right? And validation asks, am I building the right system? So those are your 4 phases. Start with elicitation, move on into analysis, go back if there were questions open, documentation, go back if you figure out, that is not feasible, there are conflicts in here, or if you find you don't have enough information to properly document this. And then once you have everything written down and you think this should all be good, go back to the stakeholders and ask them if that is indeed the case. You see these arrows here are a recurring thing.
There are many reasons why this requirement specification process is important, but the most widely cited reasons fall into two categories: engineering and economic. The engineering argument is pretty simple. Spending time up front saves time later. We make fewer mistakes which often have far-ranging impact. When we spend a significant percentage of our work timeline on this planning stage, we do much better. Don't plan anything? See your schedule and budget exploded. Makes sense. But even with just 5% planning, you can see a significantly decreased overrun. Now, notice, please, that it doesn't go to zero. Even spending 10 to 20% on requirements and scope only brings it down to 40% cost overrun, with a long tail that looks to approach 35%, but not much lower. Just another reminder that we aren't very good at estimating these kinds of things. Now, the other requirement for spending good time on requirement specification and scoping is more micro level. We said before, most problems come from this stage, and the longer they fester in the product, the more costly they are to fix once we do find them. In fact, if the problems aren't found until the product has been deployed, you can see repair costs as high as 1,000 times the cost if the problem would have been found during the requirements analysis. It's nearly an exponential increase in cost at every stage: design, to coding, to unit and integration testing, to system testing, and again, 1,000 times at deployment. Handling a requirement specification process well is crucial for the success of any software development project. Given that most problems make it into your project during this phase, it's absolutely crucial that you spend the appropriate amount of time in this stage to ensure that the problem and solution are well thought out before beginning any kind of design or development work.